All right, next we're going to talk about integration of trigonometric functions. So whenever we talk about integration, it's always good to think of differentiation in reverse. So let's go ahead and write out our derivatives of our sixth trigonometric function. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared of x. The derivative of secant of x is secant of x times tangent of x. The derivative of cotangent of x is negative cosecant squared x. And the derivative of cosecant of x is negative cosecant of x times cotangent of x. So when we write an integration of trigonometric functions, we actually use slightly different rules. So here, the integral of cosine of x. So we have to think cosine of x is the derivative. What was the original function? So cosine of x is the derivative of sine of x, which we can see here going backwards. And of course, we need our plus c for our general solution. So the indefinite integral of sine of x, so we say sine is the derivative of what function? So here, this was negative sine, would have been the derivative of cosine. So sine itself is going to be the derivative of negative cosine. And then we have plus c. Okay, so the indefinite integral of secant squared is just going to be tangent of x. The antiderivative of secant x tangent x is just going to be secant x plus c. The indefinite integral of cosecant squared. Okay, so again, we have that negative sort of thing happening here. So it's going to have to be negative cotangent x plus c. And here we have cosecant x times cotangent x. And the negative thing is happening again. So we get negative cosecant x plus c. Okay, so you can see you don't have to necessarily memorize all of these. Just think about the relationship between the derivative and the integral, how they're inverse operations. So now we can do problems involving trig functions. So here we have the integral of 2 sine x plus 3x squared. Now, when we do this, we can always separate these out. So we would get 2 sine x dx plus the integral of 3x squared dx. Okay? And you can actually go even further to take out that 2, because we know the constant will just get multiplied at the end. Okay, this one we don't need to necessarily because it's built into our power rule. Okay, so here we have the integral of sine x. So its integral is negative cosine x. So we have 2 times negative cosine x. So we'll say negative 2 cosine x. Now we have a plus c, but we'll just wait to the end to add that on. And then the integral of 3x squared. So we get to practice our power rule again. So again, we want to add 1 to the 2 and then divide by that same number. And we can see here the 3's cancel out. So we actually get negative 2 cosine x plus x cubed. And then we're just going to write plus c at the end. So what happens is, if we added a constant from this one and a constant from this one, we still have a constant. So always just add that plus c. All right, for number 2, here we have cosecant squared. So the integral of cosecant squared is a negative cotangent. So I'll just write negative cotangent x. And then we have minus cosine x. So here we have regular cosine x, and its integral is sine x. So that negative is just going to continue on here. So we get minus sine x, and then plus c. Now what would be a method for checking these? Well, we could take the derivative here and see if we get this derivative right there. So let's try it. The derivative of negative cotangent, well, would be positive cosecant squared, which is right there. And the derivative of negative sine, well, would be negative cosine. And we can see negative cosine right here. So you can always test these out. Okay, I want you to go ahead and try number 3 on your own. See if you can find this integral. You can pause the video and come on back, check your work. All right, welcome back. So you can check your work here. You should have gotten theta squared minus theta cubed over 3 plus sine theta plus c. All right, in our next example, number 4, we have the indefinite integral of sine x over 1 minus sine squared dx. So here, you're going to want to notice the trig identity right down here at the bottom. So 1 minus sine squared actually equals cosine squared. So we definitely want to get rid of this division if we can. So let's see if rewriting this helps us. Okay, so now we have sine x over cosine squared x. Okay, well, none of this stuff talks about cosine squared x. So let's actually just rewrite this now as sine x over cosine x times cosine x. Now, let's think about this. Since we have all multiplication, we can separate this out. And so I'm going to actually write this as sine x over cosine x times 1 over cosine x. Now, sine x over cosine x is really just tan x, or tangent of x. And then 1 over cosine is really just secant. So we required a little bit of manipulation, but now that we have tan x secant x, you can see that that is right here. And so we know the indefinite integral is going to be secant x plus c. Okay, so our whole goal is when you see this integral right here, we need to rewrite it. So you're going to have to use your trig identities and then your reciprocal identities and all that other stuff so that you can try to get it to look like one of these so that we can actually take the integral. So let's go ahead and try the next one. And I want you to give number 5 a try on your own and see if you can't manipulate these so that they look like these and find your integral. So go ahead and pause the video, come on back. All right, welcome back. Go ahead and take a look at the transformations that I did here and check and see that you get the correct integration. All right, so that's been integration of trigonometric functions. All right, next we're going to talk about integrals of trig functions and particularly how the natural log function can help us find some of these integrals. So we're just going to start off with a proof of these 3 right here and discover what the integral of tangent x, cotangent x, and secant x is. So for tangent x, the first thing we want to do is change tangent x into sine x over cosine x. So we're going to rewrite this as the integral of sine x over cosine x dx. Now in looking at this, we have a quotient, so we're going to use our u substitution here. And we're going to let u equal cosine x, and u prime then is going to be negative sine x dx. Okay, so we can see here that we have our cosine x on the bottom, but we need a negative sine x dx, and right now we have a positive sine x. So what we need to do is make this be negative, and then to keep it balanced, we're going to put a negative on the outside. Now we really have the negative integral of u prime over u. And this right here, the integral of u prime over u, is simply natural log. So this equals the negative natural log of the absolute value of u plus c. And all we do is substitute cosine x back in for u, and so this equals negative natural log absolute value of cosine x plus c. Okay, so that is the integral of tangent, and it actually becomes a natural log function. All right, for our next example, we have the integral of cotangent x dx. And we're going to use the same type of idea where we switch this over and make it the integral of cosine x over sine x dx. And we need to choose u in the denominator, which is sine x, and u prime then is cosine x dx. And so if I look at this one, I already have it in the form of u prime over u because we have cosine x. And so we know that this is just going to be the natural log of the absolute value of sine x plus c. Okay, so the integral of cotangent x is the natural log of sine x. All right, in letter C, we want to find the integral of secant x, and this one's a little bit tougher. So the first thing I want to do is multiply top and bottom by secant x plus tan x over secant x plus tangent x. Okay, so we're really multiplying by 1, and that's going to change our integral. So we now have the integral of secant squared x plus secant x tan x over secant x plus tan x. And this is dx. So here, we're going to let u equal secant x plus tan x. And then u prime is actually going to be, well, the derivative of secant is secant tan. So that's secant x tan x. And then the derivative of tangent x is secant squared x. Okay, so here's u prime. And if we look at our integral now, we have secant squared x plus secant x tan x, which is u prime. Oh, and we have a dx here. So this is already in the form u prime over u. So our final answer is going to be the natural log of the absolute value of secant x plus tangent x plus c. So it would have been a little bit hard to figure out that this is what you needed to multiply by, but hopefully you can see that it does work out and that the integral of secant x is the natural log of secant x plus tangent x right there. So this rounds out our integrals of the 6 basic trig functions. Sine and cosine we had already known, so it's negative cosine and positive sine, and I just proved to you that the integral of tangent u du is negative natural log of the absolute value of cosine u, and I proved the integral of cotangent u du is the natural log of sine u plus c, and I also proved secant. Okay, so the integral of secant u is natural log of secant u plus tangent u, and likewise we could have done another similar thing with cosecant, and we would have found that the integral of cosecant u was the negative natural log of cosecant u plus cotangent u plus c. So hopefully you can see the relationship between tangent and cotangent. the signs change and then it flips over, so it's cosine or sine. And the same thing with secant and cosecant. The signs change and then we have to use cosecant instead of secant, and then cotangent instead of tangent. Alright, so let's use these integrals now to evaluate some of these indefinite integrals. I should say in. Okay, so if I'm looking at this, the tangent of 2x dx, we can see that 2x should get grouped together, and that really becomes our u. So here u equals 2x, and du is going to be simply 2 dx. So you can see that we're missing a 2 here. So we're going to add it on the inside and put a 1/2 on the outside. And so now let's use change of variables. So we're going to have 1/2 times the integral of tangent u du. And now we can use this integral right up here. So it's going to be negative 1/2 of the natural log of the absolute value of cosine u plus c. And then let's replace u with 2x. And so we get negative 1/2 times the natural log of the absolute value of cosine of 2x plus c. Final answer. Okay, so go ahead and find what u is. Make sure you have du present, okay, because we need u du. And then integrate, and then substitute back in for u. Alright, so for letter B, what do you think u should equal? Well, it looks like u is going to be 1/2 x, which means du is going to be 1/2 dx. So what are we missing? Well, we're missing a 1/2 on the inside, meaning we're missing a 2 on the outside. So let's change our variables now. So it'll be 2 times the integral of cosecant u du. And now let's apply this integral right here. So it equals negative 2 times the natural log of the absolute value of cosecant u plus cotangent u plus c. And now let's go ahead and substitute in for our u's right here. So u equals 1/2 x. So our final answer is negative 2 times the natural log of the absolute value of cosecant of 1/2 x plus cotangent of 1/2 x plus c. Final answer. Alright, let's take a look at letter C. So here I would let u equal, well, probably the denominator, because I don't see anything in with the x's, so when you see a quotient, try the denominator. So let's go 1 plus 2 cosine x, and let's find du, okay, which is going to be negative 2 sine x dx. And I don't see negative 2 sine x dx. I see 3 sine x dx. So what we're going to do in this case is actually bring the 3 to the outside. Okay, so that'll be gone. And then multiply by negative 2 on the inside. And then multiply by negative 1/2 on the outside. Okay, so bring your constant multiple outside and then give us a negative 2 and a negative 1/2. And so let's rewrite this. We have negative 3/2 times the integral of negative 2 sine x over 1 plus 2 cosine x dx. And now you can see we do have u prime, right? Because du and u prime are the same thing. So we have u prime over u. So we have negative 3/2 times the integral of u prime over u. So very important, just because you have trig in the problem doesn't necessarily mean you're going to use one of the 6 basic trig functions. Okay, you might still be able to use u substitution and have your trig drop out completely. So notice the difference between the two problems. Here we had u inside the tangent function, and here we don't. Okay, so this is going to be negative 3/2 times the natural log of the absolute value of u plus c, and then we'll just substitute u back in. So we get negative 3/2 times the natural log of the absolute value of 1 plus cosine x plus c. Final answer. Okay, moving on to letter D. Here I see 1 plus secant x squared. So here, let's try to let u be the inside of our composite function. So we're going to let u equal 1 plus secant x. Okay, and let's go ahead and find du. Okay, derivative of 1 is nothing. The derivative of secant is secant x tangent x dx. Now, do you see du anywhere in here? I don't, and we can't add in anything with a multiple. So if we have no du, we can't use our nice power rule of the integral of u squared. Okay, so what are we going to do instead? Well, in this case, let's actually apply this square. We're going to get 1 squared, which is 1, plus 2 times 1 times secant x, which is 2 secant x, plus secant x squared. So we'll rewrite that as secant squared x dx. And now what we can do is evaluate each one of these integrals separately. Okay, so we do have the integral of 1 dx plus the integral, and we'll take a 2 on the outside here, of secant x dx plus the integral of secant squared x dx. Okay, so let's take the integral of 1 dx, which is just going to be x, and then plus 2 times the integral of secant x dx, which is just right here. So it's natural log of the absolute value of secant x plus tan x. And notice our u was x, so du is just dx, meaning we can just directly substitute there. And then plus the integral of secant squared dx. Well, it's not up here, but you'll recall that the integral of secant squared is just tangent x. And then we have plus c. Okay, so hopefully letters C and D can show you some possibilities, and our basic integration techniques are still the same. We try to get it always to the power rule if we can. If we can't, then we actually go ahead and apply the exponent, and then from there you can see we have 3 functions that we can integrate separately, and each of them we know the integration rules for. So here is the final answer there. And we now have more integrals in our arsenal to use in calculus. All right, so that has been integrals of trig functions.